So, good morning. Hello. Could you please pass it? Do you want to talk after class? Thomas. Could you please? So overall, the homework results are, hello. The homework results are almost perfect. Nevertheless, I will show you the complete solutions just in case that there is any question. This also applies to you so that you have the correct solutions. Oops. So actually, I did not see any problem with respect to the first two problems. Just for perfect clarity, I illustrated here the way to do it. So actually, with respect to the first problem, it is just about extending the boundary conditions in order to generalize it to the more general case. And then we end up with exactly the same solution as in class. This is, again, about the understanding that the boundary conditions pick up the conditions that we have. And here we have two conditions at 0, so for u and u prime. And correspondingly, we implement these conditions here for v0 and v1. And that's it. So a few more questions were related to the third problem. And to make sure that everybody knows how it works, I will show you the complete solution, because this is something that you may expect on the test and even the final. So it is really good to know about it. Yeah, here we have the solution for this case. So we follow the procedure. It is simply the best to look at the first k to conclude about the kn, which we need to find the gamma, and then we run into the geometric series, and the convergence condition is lambda times b minus a. Of course, b is considered to be bigger than a. Absolute value of is smaller than 1, and this brings us to the final solution. In this regard, we have to deal with two conditions. Actually, one is the convergence condition for the geometric series, and the other condition is the condition involving the maximum over the interval considered, the m. This was actually our condition to conclude about the uniqueness of the solution. And the e to the b minus a is bigger than 1. That means the general condition is a stronger requirement than the condition on the convergence of the geometric series. I think in 50% of the cases I saw the correct stronger condition. Otherwise, I think I had to take a half point off, but you got it back via the bonus for the nice writing. So, so what I want you to see here is that there are two conditions, and the general condition needs to be stronger than any conditions on the way to get the final result. Yeah, after all, very nice work. Is there any question about this? Okay. So what I will do in the following is that, so we finished the calculus of variations, and I will begin immediately with the final preparation. So I will show you a summary of all what we did so far, including, of course, a summary of the last things. So after test 1, and this will bring us to test 2 on next Monday. Next Monday. There will be not any big surprise. It follows the homework, and you will see a problem like this here. And obviously, I will show you a summary, and you will have a perfect idea of what you will see on the test 2. And with that, you are perfectly prepared for the final. There will be no other stuff involved when it comes to the final. So the test 2 preparation in conjunction with the summary of that what we did regarding the first half of the semester gives you all what you need for the final. And as you know, you can watch the videos as often as you want and look at this again. Yeah?
Do you ever know when the final is?
According to my knowledge, it is on December 15th. I have 2 finals. One is, I think, at 8 and one is at 10. I don't know about the time for us. I will try to look it up.
We're planning to have one.
At 10, yeah?
Or the 8 o'clock
Hmm?
one. On our final schedule, it's at the 8 o'clock.
At 8 o'clock. Okay. So you're still fresh. Very good.
So, is there going to be any questions on the second test from diffusion equations?
There can be questions on the diffusion equation. Let's do it this way. I show you a summary. This is all what you can expect. And if you feel that there's anything unclear, just ask when it comes to the point. Yeah? But it will be for sure about wave equations, diffusion equations, calculus of variations, Sturm-Liouville. So I promise you will have a very good idea of what you will see on the final. And again, the final follows the first 2 tests.
No, I was talking about the second test, actually. Because we didn't do actually.
No. On the second test, there will be nothing on the diffusion equation.
Okay.
Yeah, this is related to the first part. We talked about the diffusion equation, first of all, with the objective to talk about the Green's function representation. Yeah? So there's nothing on the second test. Yeah, so let's begin with a summary. I would like to have the time that we need to go through this. And after that, we will still look at other things, but this is just to show you what you still can do, but it will be not on the final, okay? Yeah? And in your case, I will try to double check with Ella and Dr. Pankovic regarding the test, okay? So I will present it in two parts, following the structure of the two tests. This is about the first part. So just to make it absolutely clear, this is already finance preparation. I know from previous years that it is sometimes surprising how much time is needed to go through this again. We will also look at new things, okay? So we will also talk about the connection between several parts. And if you want, of course, you can watch this again before the final. will first write it and then I will talk about it again. Yes. So one of the most important questions actually is to decide whether the equation is linear or not. That makes quite a difference, okay? And if you decide that it is linear, then we follow our usual approach. What I saw is that everybody knows exactly how we have to set up the differential equations. And we talked about solution structures, and the format of the final will be the same. You can certainly use your materials, the textbook, whatever. So you will know how to solve these equations. My advice is to double check solutions. Maybe you are stressed or not, I don't know. But after solving these ODEs, it looks so simple in each case. But it is a good idea to ask whether your solution satisfies the initial condition for this equation. And the equation, it takes usually a minute or so, but it is certainly worth to do it. And then it is about converting between s and tau and x and y. And this looks, again, relatively simple, but it is good to double check it to come to the correct answer. And when you finally derived your solution, usually it is very simple to double check whether it satisfies the initial condition. And you should certainly do this, because if there's any problem, in most cases we can see it by simply asking whether the solution satisfies the initial condition. So that is simple and a good thing to do. So with respect to a nonlinear equation, we set up again the equations. In this regard, one major thought should be whether you can simplify the u equation by using the differential equation again. This can make the difference between doing calculations for 30 minutes more or less. So it can be highly efficient. Yeah? So when you have a complicated equation in U according to its definition, involving many terms that you do not really appreciate, and it turns out that you can simplify it to u dot equals 2u, that makes a difference. Okay? It also makes a difference to ask in which way the p and the q actually come in. And you can solve a linear equation by using the formalism for nonlinear equations, and you will find that the p and the q do not affect the solution. Yeah? So that is also something to look up. Otherwise, I think you know how to add the additional conditions to solve for p naught and q naught. So I wrote it again with a plus on the left-hand side to make it clear. The formalism then is the same. At the end of the day, we simply want to get the s and the tau as functions of x and y in order to produce the solution. How does it sound? Very good. So we also had a quick look at systems of equations, and just to remind you about the approach in this case, I will mention it again. So I showed you the example for the Cauchy-Riemann equations, where we would like to solve for a vector of functions u and v. And the idea is to differentiate these functions again in order to produce a higher order equation for one function. Yeah? So this makes a Laplace equation. At the end of the semester we will talk about the solution to Laplace equations. The same applies to v then. So what we would like to have is an equation for one variable. This follows exactly the philosophy with respect to ODEs, where we can do the same. So when you look at any equation, what is the first thing to do?
Can we represent it with function?
That is correct. But in your own interest, the thing to do before that is to look at the domain. Because it makes a major difference which sort of approach we have to use. So when it came to the first test, there were some attempts to apply methods that do not apply at all to the type of problem considered, which is not good. So the domain decides about the approach. And this is something that is so important. So we derived in the beginning of the semester D'Alembert's solution, which is pretty good. When you see a problem like this, I would never expect you to derive the formula again. It is about using it. This applies to all problems. So when we talked about a solution approach, the thing is simply to get it done. However, so you need to come to the correct solution in the quickest and safest possible way. So when it comes to data functions, it needs an understanding of how to use these things. So when you have f and g of x, it definitely needs to plug in the g as a function of y, and the f is taken with the argument x plus ct and x minus ct. When we did this stuff, we did not make any attempt to talk about Green's function at this point. We moved on to Green's functions when we started to talk about diffusion equations. So this is stuff that you did not see before. And I do this in order to show you the bridge between these methods, and actually to also show you that we can certainly use the Green's function approach as a general tool. It is in no way restricted to diffusion equations, okay? And here I showed you how to get the corresponding Green's function representation. Look again at the structure. There's only data input. There's not any factor of 1/2c or something. All this goes into the definition of the Green's function, and then we have integrals from negative infinity to infinity, and we see the Green's functions in several variations, and here with respect to this problem we only have the chance to get the derivative of the Green's function. We talked about the Green's function several times. What do you still know about it? Yes. And with respect to this case, what would be the quickest way to show it? So let's say the point is to show that the Green's function is a solution, yeah, to our problem considered for certain input. Yeah?
It's different. The function is delta function.
Yeah. And here we have f and g. So what can we do to make it really simple? So it's the f goes with the derivative of g by t. Yeah. So let's say f is equal to 0. Yeah? And then what is the problem that is solved by the Green's function?
F is 0 and g is not 0, right?
F is 0 and g is non-zero. And the question is what should be the g to make, so the little g, yeah, to make the Green's function a solution?
A delta function?
Yes. So if the little g is a delta function, so delta of x, yeah, Then we plug it in as delta of y. The peak is at 0. The only non-zero contribution of the integral is at 0. Therefore, we can replace the Green's function by g of x and ct. It is not affected anymore by the integral over y. The delta function integrates to 1, and the conclusion is that u of x and t is g of x and ct. Yeah? So this was with respect to the wave equation, and just to summarize it, also for the diffusion equation, I will show you the following. So here we introduce immediately the Green's function. It does not make too much sense to look at any other option. And that was our result. And just to repeat it, this is a one-dimensional normal PDF centered at y, and the variance is 2at. So what I will do next time is to continue with this stuff, and then we will move on to a summary of what we did last time, and this is then the test 2 preparation. I need your homework with the idea to give you the graded homework back before the test, so that you know about any potential problems. Okay? See you next time. Bye-bye.